Okay, let me talk to you now about the dry ice. We started in class to talk about some of those ideas, questions that you had, but let me continue here now in this podcast. So we did lots of investigations in class. We put dry ice in a film canister, hot and cold water, placed the coin on the edge, things like that. And you came up with lots of questions and made lots of great observations. So just as a reminder, let me show you a couple of things. Here's that one film canister that I recorded. Oh, the anticipation. Yeah, that was pretty cool. All right. Then we also put a coin in the dry ice, and this is what happened. Notice it's bouncing back and forth. We know now that dry ice is frozen carbon dioxide, and it misses the liquid stage. It goes straight from a solid to a gas called sublimation. So when we take an object that has a temperature that's warmer than the dry ice, like a coin, and we stick it down inside the dry ice, the ice is sublimating while the coin is in there. So picture my finger like this. So if this is the dry ice down here, the heat energy from the coin, which is room temperature, is actually causing the sublimation to take place. So the solid is changing to a gas. Well, as it does that, a gas spurt jets out this way and pushes the coin over. But on the other side, there's another gas spurt, pushes the coin back. So as that continues, the coin will continue to vibrate back and forth as the gas is pushing it back and forth because of the heat energy that's in the coin being transferred to the dry ice, causing the ice to move, the dry ice to sublimate from a solid to a gas. Now, if we leave that dry ice and the coin just sitting out on the table, you'll notice that a frost film forms over the top of both the chunk of dry ice and the coin itself. I'm going to ask you to make a prediction as to where you think that ice formation came from. I'm not going to answer it right now, but ask me next week in class. So in your notebooks, jot that down. Okay? How come this is covered with ice? Where did that come from? Now, we did the boiling water graph and we saw what happened to boiling water. This is a different kind of graph that shows us the properties of dry ice. So we know that this is carbon dioxide, and we're going to start in the bottom left-hand corner. So this corner piece down here on the y-axis on the left-hand side measures atmospheric pressure. In our rooms right now, wherever you're seated, about 1 atmosphere of pressure is pushing down on top of you. That's just considered normal on Earth, 1 atmosphere of pressure. Where this red line is, that's 1 atmosphere of pressure. Then you can see the temperature along the x-axis. We have minus 78 degrees Celsius. That's pretty cold, okay? So we also see this black line that represents the graph itself. So if I come across from the y-axis at 1 atmosphere of pressure to the black line and go straight down, I can read the temperature is minus 78 degrees Celsius. So when you were handling that dry ice, that's how cold it was, minus 78 degrees Celsius. Now, if you look over here, I know this is the English spelling for the word vapor, but this represents, and this whole area right here represents a gas. So anytime the temperature is anywhere from 0 or below minus 78 degrees Celsius and 1 atmosphere of pressure, it's going to be a gas. And in fact, it's going to be a gas all the way up to whatever temperature you want. It's going to just simply be a gas. Okay? In order to make it a solid, it needs to be in this area over here. So it needs to be really cold, less than minus 78 degrees Celsius, okay? So that the freezers that they keep dry ice in are actually lower than minus 78 degrees Celsius. You'll notice over here at 5.11 atmospheres of pressure, there's a green line that goes over to this point right here. This is called a triple point because the 3 phases come together at this point. You have the gas, you have the solid, and then you have the liquid stage that happens in this area of the graph. In order for carbon dioxide to be a liquid, it has to be above whatever temperature this is right here, and I don't know what it is, but it has to be above that temperature. And let's just, for kicks and grins, say it's, I don't know, minus 50 degrees Celsius, but it has to be above 5.11 atmospheres of pressure. So one of the ways in the past that I've been able to actually get liquid carbon dioxide is to take a medicine syringe and seal off the end of it so nothing can come out that little opening where the needle goes. Pull the plunger all the way out and put some dry ice in the plunger, stick the plunger back in, but then I plug up the plunger so it's stuck in that cylinder with a nail. I just run a hot nail all the way through there. So now it's got a place where, like your film canister, it can build pressure, build pressure, build pressure, but it doesn't blow the top off, and it allows that atmospheric pressure inside the cylinder to be over 5 atmospheres of pressure. Once that happens, the carbon dioxide solid turns to a liquid. Now, if you go on YouTube and just do a search for dry ice bombs, you will see that people actually make dry ice bombs. They'll take a 2-liter pop bottle or a 1-liter pop bottle, and they'll put dry ice in it and liquid and screw the cap on. When they do that, once it reaches, a pressure that will burst the plastic, you get this monstrous explosion. If you do that, do it under the supervision of adults, because that's extremely dangerous. The materials that I had for you in class were safe materials. That's why we used a film canister instead of a 2-liter pop bottle. But you can actually create a really bad explosion. So just be really careful with that. All right, so I want you to be sure to make a copy of the graph that you see here and put that in your notebook. And hopefully at some point you could explain what's going on here. Now, there are real life applications to having dry ice. One of those is it's really readily available here in Bozeman because people hunt and fish. So when you catch fish, and if you're from Minnesota, you want to pack it, freeze it, pack it, and take it home, you use dry ice to pack it in. Same thing with hunting. When people come here hunting and they have shot something and now the meat's processed and frozen, then they can transport it that way. There's other applications too, and one of those is like for gasoline tanks, big monster huge cylinder tanks that are buried in the ground. You don't want to be crawling in those and lighting torches and fixing the tank itself. So you can put dry ice in there. As you notice today, when the dry ice crystal ball bubble broke, the dry ice went to the bottom. That's because the gas itself is more dense than air. So then if you've got a cylinder, like a big gas container or something that's full of fumes, if you put dry ice in there, the carbon dioxide will fill up from the bottom and push all the other fumes, the gas fumes, the oxygen, and everything else out of there. And it'll be safe then to go in and actually repair those containers. Okay, so that's what I had for you today. Make sure you're taking notes off of this and go ahead and work on your other homework assignments. Okay, thanks, bye.